Now I'm going to start talking about numeric data. Now, when we're talking about numeric data, we have this group of data, and I don't want to make each number something because there's too many possible numbers. So, I mean, there's a few things I could do to organize this data. I could sort it, and that would help a little bit. But I really want to see like shapes and things like that. Now, this doesn't really have a shape up here. So we're not looking at a shape when we're looking at a bar plot because this order doesn't matter. The orders of the pets didn't matter either, how I had it in there. But in this, order does matter. So what we're going to do is we're going to create a frequency table, but we are going to create a class limited frequency table. So I want to make 7 classes or groups, and they have to be equal size. If they're not equal size, you're essentially turning them then into more categorical data. And even if that categorical data is ordinal, you're still turning it into ordinal data. So we want to keep the 7 groups equal size. And by equal size, I mean by not the number of numbers in there, but by how many possible numbers that are in there. Does that make sense? Like I want to go 36 to 45, which is 10 possible numbers, no matter how many there are between 36 and 45. When I say equal size, that's what I'm talking about. Equal possible size. So we do this by taking the max minus the min, and we divide that by the number of classes we want. It's good to have about 6 to 10, depending on your data, depending on how big your data is. That's what usually looks nice and that we can process with our brains. So when we do that, we have to round up. Even if we have a whole number, we have to round up again. Or what happens is it tends to go into that last number goes into an 8th class. We don't want to do that. So what we're going to do is we're going to start with the lowest value we have. We're going to do that. Sometimes, depending on the value, it's easier to start with something, a whole number or something like that. So if the numbers aren't a whole number, sometimes it's easier to say, well, I'm not going to start at 0.45, I'll start at 0 or something like that. So we start out, we go 99 minus 36 is 63. And because I can see what the highest and the lowest is, 99 and 36. Now, I'm going to show you really quick how we can put this into Art of Stat. Now, if you have this isn't going to work because this is just kind of a picture, but I happen to have it. Well, I happen to have it I copied and pasted to an Excel file, which I will also paste in the chat box. Oh no, that didn't work out right. Terrible. Okay. I'm going to put this into Art of Stat first, and then I'll do it. So when I go to Art of Stat, I'm going to now explore quantitative data because I have numerical data now. And I'm going to say I have my own, and I have individual observations. There we go. Now I'm going to, that hopefully will work in the chat box. Yeah, that's better. Here's the numbers I put in chat for you if you want them. And so look what it does. It does a lot of things. So it gives me the sample size. We'll talk more about mean, standard deviation, everything next week. But it also gives me the max and the min. so that I'm able to take that max minus min, 99 minus 36, and get 63. So that's what I'm going to do. So let's go back over here. And I'm going to go, well, 63. Now I divide by the number of classes I want, which is 7, which is 9, but I need to round up to 10. Because then it'll be all kind of weird if I don't. I'll have a class with nothing in it if I don't. So what I'm going to do is I'm going to write down what the possible ages are. So it's going to be 36 through 45, 46 to 55, 56 to 65, 6 to 75, 76 to 85. And you'll notice something here. I'm not using the same number here. I'm using the next one. And this is actually just the total. So what I'm doing is the beginning steps up by 10 every time. So this is 36, this is 10 more, 10 more, 10 more, 10 more, 10 more, 10 more. And then the ends are 1 less. Because my data is written in such a way that there's nothing between, I can write it up to and including 45. Now we could also write it, in this kind of format where you're including 30, this is 36 to 45 up to, or I'm sorry, 46. Up to, but not including 46. But that doesn't really need to be done because it's already done. It's 45, right? There's nothing going to be between 45 and 46, so we're good to go. Now, how can we easily find these frequencies? Well, we could go in here and hunt and peck. Okay, 36. Where is the other one that's less? I don't know. No, that's the next one. I know there's supposed to be another one in here somewhere. I can't find it. I thought there was. Oh, 38, yeah. So there is 2 there. But those were hard to find. It took me a while to find it. So the easy way to do this is to go back to our handy dandy exploring quantitative data. Now, this is called a histogram. We're going to talk about histograms in a minute, but I can adjust the bin width for this histogram. So that's what I'm going to do. I know what I want. I figured out the bin width was 10. That's how many numbers I have, right? So each starting point is 10 more than the one before it. That's my bin width. Then I'm going to select my starting bin where I want to, which I started it at 36. So now that I do that, this has the 1, 2, 7, 1, 2, I said 7, because I was getting ahead of myself, 3, 4, 5, 6, 7. So this now has 7 bins. But look, each one of these is, this one goes from 36 up to 45. This one goes 45 to, or 46 to 55, 56 to 65. And you can see how each one of these is starting on the 6 of the next one. And they're going up to, but not including that 46. So we have all of the frequencies if I roll my mouse over. So I have 2, 7, 9, 9, 6, 4, 3. So let's put that in here. So I know that I have 2, 7, 9, 9, 6, 4, 3. Is that right? That's 18, 27, 30, 40. Okay. That's 40 total. And now you want the relative frequencies. Watch this. To get the relative frequencies, I'm going to hit this button called display percent. Click on that. Now this changes the histogram to percent. Now these are all in percents. So to find the relative frequency, I have to convert back to decimal. But 5% is 0.05. Right?
Mm-hmm.
Say yes. Oops, get over there. I want you there. No, I don't want it there. There we go. It keeps wanting to do what I don't want it to do. There we go. Okay. So we can go over these. And this is 5% or 0.05. Roll over this, 17.5%, 175. 22.5%. 15%. 10%. 7.5, which is 0.075, and the total should be 1. So even though it doesn't easily give you a little table like it does in the previous one, you can still get the answers using this. So kind of nice. I mean, really all these are 2 divided by 40 is 5%, right? 2 divided by 40, 120 is 5%. 7 divided by 40 is 17.5%. So you're getting the idea. 4 over 40 is 1/10, 1.1. Okay. So that's a nice, easy way to get yourself a frequency table. Now, what about continuous data or data with decimals in it? So here's some raw data. I made it really small. And what I basically do is I just make the endpoints 1 times 10 to the negative k less than the start value of the next class. So again, this is 0 up to, but not including 25. So I can take this data So if I take this data and I go to here, excuse me, catching a bit of cold, so. All right, so there's my new data. And lower bound of my first bin is this. I'm using 25. And you can see that these relative frequencies are the same as what I have here. And so this one is 0 up to, but not including 25. Okay. Excuse me. So let's move on. Oops, we're not there yet. So let's talk a little bit more about these histograms. So a histogram, you'll notice that the boxes were adjoining. And that's really big in histogram. I'm pretty much a stickler for a histogram having adjoining boxes. Those should be touching. This data is ordered, and that should be, the boxes in a histogram should be touching. I'm kind of strict about it. So the other thing I'm kind of strict about is the way the horizontal axis is labeled. Shouldn't be a problem with yours because you're going to be doing this in the computer. And so it should be fine. Okay. And then, so what you're doing is that horizontal axis, don't label that like a bar graph. You want to label that like it was in that quantitative. You want to have it where you are showing that this is 0, this is 25, 50. It doesn't, you don't have to label every bar, but you'll notice this is not labeled like a bar graph though. So these are I'll just let you look at this for a second while I take a more drink and try not to cough. So a few things, of course, bars have to touch. You guys know, you guys can read all of that. And if we take a look at this, I've showed you how to use explore quantitative data to make all of these. And this is basically what I had done. This is just the instructions to everything that I did on that problem. And the next thing is stem and leaf plots. So the same data for a stem and leaf plot, I'm not going to spend a lot of time on this because I'm going to show you something very cool. If you explore quantitative data, choose type of plot, stem and leaf. There it is. That's for the first data, the second data we were using. Now you'll notice something weird about it. A stem and leaf plot generally has the first digit to every number over here on the left side. In this case, we do not. In this case, it has 0, 2. So this is representing the zeros and the ones. This is representing the 2s, and the 3s, 4s, and 5s. I don't like that way. So I'm going to lengthen it. So I move over here to select length and make it so it's showing me everything. So this is showing me, the zeros. So the $6, because it has $6, $7. And what this did is it just rounded everything off to the nearest dollar. So this 191, 191, and so forth. And that's what this particular problem did. If I put my old data back in there, which I'm going to grab and put that back in, you can see the stem and leaf plot. It's long now. I'm going to make it back to medium. You can see how pretty that stem and leaf plot is. Excuse me for 1 second. Okay. All right. So now when you make this one long, what it does is it now goes, the first value is 0 through 4. The second value of the same, this is 2 lines per stem, is now 5 through 9. So see the 5s, this is 50, this represents 50, 51, 51, 53. The second one represents 55, 55, 56, and 57. So 0 through 4s, 5s through 9s go on the second line of the same stem. But that doesn't look very good. That's too many. It's spread out too much. So we would probably for this data use the medium, and then that looks really nice. And I think that's a lot easier than doing them by hand personally. But I think it's all right. But if you want to do it by hand, I kind of have the instructions here. And there's a couple of the videos on it. And then this is also an example of one with 1 line per stem and 2 lines per stem. And you can see how when you have data like this, that's kind of close together, you would only have 4 if you just did it this way. But if you did the 2 lines per stem, you'd have enough to kind of see a shape in it.